So in this video, I'm going to demonstrate the usage of our JavaScript and TypeScript rich text resolver, both in its primary intended use case, which is resolving rich text linked items and components, and we'll also delve a bit into other tricks that are possible with the rich text resolver, which weren't originally possible in the legacy resolution of the JavaScript SDK, which was built into it. So for the purposes of the demonstration, I'm going to use our sample project, the multi-brand sample project. You can create one yourself if you haven't done so already. Just go to projects, create new project, and select the multi-site sample project, and the wizard will guide you through the process and create a copy of the project in your subscription. Now, as for the code of the sample application, you can find it in the GitHub repository of Kontent.ai, on the Kontent.ai repositories, sample up Next.js. I already cloned the repository and opened it in my editor, so we'll start there. Let's start with the components. In the sample application, I believe the only type that was intended primarily for the inline usage in a rich text element was callout. You can, it's actually annotated with this puzzle piece. If we open the type, we'll see that it's intended as a, it's part of the component guidelines snippet, but yeah, it explains that it's intended use is as an inline warning or an info box, etc. So the actual usage in our in the sample project is under Ficto imaging collection, and it's on the research item. So let's open that. Yeah, so this is the page, Ficto imaging, and the item itself is actually a content chunk, which is our container for rich text content. And we can see that the callout is here, and it actually just informs the user that this content is not finished yet. If we open the application here, so this is the sample application for Ficto imaging, and yeah, under research, there should be the component. Now, we don't see the component here yet. That's because I actually commented out the piece of the code that's responsible for the resolution. So let's jump into the code and have a look at that. Right now, like I've said, it's commented. If we open the console, just a quick look, we'll see that the sample application is some sort of handling for such cases, and actually it doesn't display this div block, but it informs us in the console or in the source code of the source HTML that this is an unknown block type, and there's no component for it. We'll get to it later, or actually right now. So if we open the code of the sample application, we can go to rich text element, which contains the logic for rich text resolution using the rich text resolver. Now, the usage of the rich text resolver revolves around portable text resolvers. Though those are either React or just HTML. And actually for React and HTML, these are built in, the rich text resolver. Otherwise, you can also use external packages for Vue or other frameworks of your choice. But it's currently, the resolver only exists as a TypeScript. So yeah, basically any TypeScript-based or JavaScript-based framework most of them are supported. In our case, we're using React, so I'm using the utilities from the React part of the resolver tool. And what we do here is that we are actually wrap this into a function that is to only to provide the resolvers with the required information about the element. So of course, if you want to resolve a component or a linked item, you actually need to provide them to the resolver. So we do that here. The element as you can see, is typed from the SDK. So the method expects a rich text element pulled from the SDK. And now the structure of the resolvers is as follows. Now most of the resolution happens under types element of the resolver object, and you can see there are some already pre-filled. We've got image and table here. Now, if we have a look at this, we can see that this is also typed. This is actually because we provided helpers that contain type definitions for custom components that are specific for Kontent.ai when it comes to portable text, because portable text is what the resolver is built upon. And the custom blocks are for images, for tables, and for our components. Now, like I've said, I've commented this code out, so that's why we didn't see anything before. Now, if I comment this or uncomment this again, we can see a bit better what's happening under the hood. So what we do here, we've again components and linked items are handled under a single component or item property of the resolver, and again you can see that it's typed already, so no hassle in typing the values here. Just shorthand access of the value property, which contains under the portable text component or item. We can actually have a look at the type definition. We can see it comes from the rich text resolver package, and it basically just it defines a custom block component or item. There's also a data type property which holds either link, item, or component. So yeah, it's either for linked item or component, or rich text link as well, possibly. And then there's the actual component or item, which is basically just a reference to the component or item that that's returned as a part of the API response from the SDK. So what we do here is first we check, we try to find the component or item based on the value that we've passed to the component or item resolver. So what this does is it looks for linked items. Again, we mentioned this is the element that comes to the default create default resolvers method, and it gets it's checked. Basically, the linked items array, which holds all linked items and components of said rich text element, is iterated through, and the corresponding component or item is found. Now, if it's not found, which shouldn't be the case ever, but there's error handling for that, just in case. So there's just an error thrown, and otherwise we go here. This is where the magic happens. And you can also use a different structure, but in this case we're using switch. And basically what we do is we switch to the component or item that we've isolated in the previous step, and we look at its type. Now, type is basically a code name of the type that the component or linked item is built upon. And as I've shown you earlier, we have the callout type that we want to resolve to a warning message. So, yeah, apologies for that. Let me jump back into the code. Yeah. So as we can see here, we check if the item or component is of type callout. Then we return some sort of component. Now I can save this and actually show you what the component looks like. It's provided basically the component item is provided as a prop to the callout component, but we'll adjust this just to show you the possibilities. So let me jump back into the application. Let's close this, and we can see that it updated the moment I uncommented the code. We see now that there's the callout rendered. Now this is again the callout is rendered based on the callout component definition, but we can actually adjust this and try to return something else. So let's just say we want to return if that says callout. All right, it's enough for now. So yeah, and I would just return callout, but that's of course not really informative. We would like to also include some values from the actual component. So what we can do here is component item elements title, I believe. Is that so? Yeah. Right. Oh yeah, we actually have to forget. We need to, yeah, title and value. And yeah, this can be undefined if the text element is empty. But if I go back, I'll see that there's actually no title. So expect nothing to render there. Let's try to save this. And that's true. There's no element called title. But if we look back, we see that there are elements called content and type, which is basically multiple selection. So let's just render the content part. We see that it informs the user that this page is not finished yet. So let's just go here and switch from title to content. And it should be present. So if I switch back to the website, we see that this the paragraph from the callout component is rendered here. Now, of course, this on its own doesn't look so well, so that's why we defined the rendering in a callout component, which is styled, and yeah, you have seen it earlier. It's this styled info box, and basically warns the user of what I mentioned earlier, that this is an unfinished page. So that's for the component. This works again, both the same works for components and linked items. But I promised you that I'm going to show you some other tricks that are possible. Now for this, we can go a bit lower. Now I'm not gonna go deep into the structure of the portable text. If you're interested in that, I suggest you either look up the portable text standard or just go to our company repositories under the Kontent.ai that I've shown you earlier and look up the rich text resolver. The repository contains documentation that will inform you further about the functionalities and the custom components we have provided. But let's scroll down. You've seen that so far we've worked with types. Then there's also marks, which usually define like links and decorations of the text, such as bold, emphasis, and stuff like that. But when we scroll down, we actually see there's a property block, and this actually allows you to transform the paragraphs or headings as well. And what we used it for here is for creating anchor links. As you can see, these are basically definitions for the corresponding tags in the rich text. And what this does what this allows you to is basically whenever you encounter an H1 tag, you can transform it to something else, such as into an anchor link, as we do here. So let me jump back to the browser and show you the homepage of Ficto Imaging. And you see there are several headings, and these are already actually transformed, as you've just seen. If we click on this, you see it takes us to an ID our vision, and yeah, this way you can create anchor links in rich text. Now, just to explain a bit more what happens here, what we do is basically just wrap the H2 or H1. Actually, it goes from H1 to H6, I believe. So all headings are accounted for. And it basically takes the H1 tag and its content is actually in the value here that we also access as children. And what we do, or actually no, it's under the children. This is the React node that contains the actual content of the H1 tag. So we just wrap the children into an anchor tag, and here there's magic that happens under the hood. You can use any ID whatsoever. You can generate an ID and just make sure that the ID of the H1 tag matches the ref parameter of the ref attribute of the anchor. But if you want to have verified links, such as we do, as you've seen, that this actually contains the text, our vision, you can do something like read it. And that's basically, we took the first child of the H1, which usually is the text content of it. and just remove the spaces and instead replace them with an underscore. And that's basically what it does. And now if we look at the rendered anchor link, again, we can jump into code or the HTML. And yeah, we see that the ID, our vision actually matches the attribute of the anchor tag under it. So this way you can create anchor links using the rich text resolver. Now, I think that's about it. There are also other possibilities to resolution, but I believe that components and perhaps the anchor links are one of the most common use cases for the resolution. So I think we went through that. Again, for more information, I suggest you go to the repository of the rich text resolver, or if you want to familiarize yourself with the portable text format, you can find that in its own repository for portable text. And also you can check their other frameworks or JavaScript frameworks that have packages for resolution of portable text that you can also use, as the portable text standard is supported and it's built upon, and actually the resolver is built upon it. So yeah, if you stayed until the very end, then thank you for your time, and hope we will see each other again in another demo session.